In this video, we're going to study multiplication and simplification with radicals. So first of all, there's the rule. And the rule is for any non-negative numbers, now recall non-negative numbers means that they're greater than or equal to 0. So our a and our b are both greater than or equal to 0. And any natural number, and we go, whoa, I forgot what natural numbers are. Natural numbers are the counting numbers. Numbers like 1, 2, 3, 4, etc. Not fractions or anything. Just the whole numbers, but not counting with 0. So for any non-negative numbers, a and b, and any natural number that we are going to call the index, we have this root, the kth root of a, times the kth root of b equals the kth root of a times b. We just multiply the radicands. But this also means that we can go the other direction, since it's an equality. We can say the kth root of a times b is equal to just the kth root of a times the kth root of b. These are done for two different purposes. The first one is when we're doing multiplication, and the second one is when we want to factor things out. So let's look at some examples. First of all, we have the square root of 7 times the square root of 10. Now, I want you to remember that you should pause the video at this point and try to do it on your own, and then unpause it, and I will have the answers. So pause your video, work it out, and here's the answer. Get the square root of 7 times 10, which is the square root of 70. Here's the next problem. The cube root of 9 times the cube root of 17. So pause the video and work the problem. And here's the answer. Third problem, we have the 6th root of 9x cubed times the 6th root of 12x to the 5th plus 9x. So you're going to pause the video and see if you can figure this out. And this is what happens, is that we multiply the two of them together, the 9x cubed times the quantity 12x to the 5th plus 9x. And then we distribute it through. It's all underneath the 6th root sign. When we distribute it in, we have our final answer there of the 6th root of 108x to the 8th plus 81x to the 4th. And here's another problem. At this time, we're going to be working with factoring. So we're starting off with the square root of 24, and we think about that, and we can break it up into the square root of 4 times the square root of 6. But why did I use 4 times 6? Why not 2 times 12? Or why not 8 times 3? All of those could have gotten me 24. We wanted 4 times 6 because the 4 is a perfect square. This is an index of 2. We want perfect squares. We want to factor out those perfect squares. If this was an index of 3, we would want to factor out perfect cubes. If it was an index of 4, we would want to factor out things that were perfect multiples, the things that would have been to a power of 4. So we've got this square root of 4 times the square root of 6. Well, that's 2 times the square root of 6. Here we have another problem. We've got the square root of this polynomial, 3x squared, plus 12x plus 12. And we notice that all three of those terms are factorable by 3. So we're going to take out the 3, and now we have the square root of 3 times the quantity x squared plus 4x plus 4. Noticing that x squared plus 4x plus 4 is factorable itself. So we get the square root of 3 times x plus 2 quantity squared. Well, what can come out of a square root is anything that's being squared, so x plus 2 can come out. So we have x plus 2, root 3, but is that our final answer? Remember, this is a square root. That's an even index. We need absolute values. So the answer to this problem is the absolute value of x plus 2 times radical 3, and that's our answer. Now, let's look at this multiplying and simplifying. So we're going to still do some multiplication, but then we're going to simplify after we've multiplied. So here's an example of a problem. And remember that you should pause it, try to work it out on your own, and then come back to the video to see how I worked it out. So first of all, the way I worked it out is I've got the outside, I have this 3 and 5, so I know I'm going to be multiplying those together. And then both of those radicals, they have to have the same index, by the way. rule was the indexes were the same, and these are both cube roots, so I put them all under one radical symbol with cube root, and we have 12 times 6x. Now we can multiply the 3 times the 5, but what's underneath that radical now? I'm looking at the number 12, and this is I believe is the best way to do this simplification portion. I look at 12 and I realize that that is actually 3 times 2 times 2. And then I look at 6x, and I realize that, well, that's 2 times 3 times x. And then look there at those 2's. I happen to have 2 times 2 times 2. There's 3 of them, and this is an index of 3. Since that's actually saying 2 cubed, 2 gets to come out of the radical. So I'm going to have 15 times 2. But what's left behind is when I don't have groups of 3, with anything to the power 3 that is still there. Well, I still have that 3 times x. So that's what's left in the radical. And simplifying that out, I get 30, the cube root of 9x. And that's the final answer. Let's look at the last one we're going to do here. And this time we've got some binomials. One of them is a binomial cubed. The other one's a binomial to the 6th degree. Both of them, I want the 4th roots. So pause the video, try to work it out, and then once you've worked it out, start the video again. Okay, well, first of all, I combine the two of those. Since I'm doing to the 3rd and to the 6th, you add the 3 and the 6 and you get to the 9th. So you've got x plus y to the 9th, and I want the 4th root of all of that. And now I like to break this up and see that the 9th power that I've got there, that can be broken up into x plus y to the 4th times x plus y to the 4th times x plus y to the 1st. The 4, and the 1 add up to the 9. And this is still the 4th root, so my index is 4. Since my index is 4, that group of x plus y is going to come out of the radical. And this group of x plus y is going to come out of the radical. So I'm going to have two groups of x plus y that will come out. And this little one says, well, it gets to stay behind under the radical symbol. So we've got two groups, so x plus y squared times, that should have a multiplication symbol in there, times the 4th root of x plus y. And that is our final answer. And this is your end of your video.